Welcome to the Explainer. Today, we're completely demystifying the supercharger. We're going to break down the fascinating mechanics of forced induction and figure out exactly how we force engines to breathe deeper, run harder, and literally shatter their natural limitations. Here's our quick roadmap for today. Number 1, the quest for more power. Number 2, 3 flavors of forced induction. Number 3, a real-world Mustang kit. And finally, number 4, the future with electric and diesel. All right, part 1, the quest for more power. Let's start with the big picture here. To really understand the supercharger, you first have to understand the fundamental problem with a standard naturally aspirated engine, and that comes down to volumetric efficiency. See, a standard engine basically relies on the vacuum created by its pistons to draw in air and fuel. But it's not perfect. Thanks to atmospheric conditions, temperature, and just general air path restrictions, a standard 2-valve engine usually only hits about 88 to 95% volumetric efficiency. So if you've got a massive 7.2-liter engine, it's actually only breathing in, say, 6.3 to 6.8 liters of air. And you can't just dump more fuel in to make power. You absolutely need the exact right amount of oxygen to burn that fuel. So to force an engine to reach or even exceed 100% efficiency, we have to artificially pack more air into those cylinders. And innovators have been obsessing over this for well over a century. I mean, look at this. From the very first Roots prototype way back in 1849, all the way to the first supercharged race car in 1908, the goal has always been exactly the same. Compress the air to make it denser so we can burn more fuel and create a much, much bigger explosion. Which brings us to part 2, 3 flavors of forced induction. How do we physically make this happen? Well, there are 3 primary mechanical variations of these air-pumping machines, and comparing them reveals some pretty massive trade-offs. You see, different driving styles require totally different supercharger architectures. A drag racer, for example, they want instant boost right off the starting line. But a track driver, they're going to prioritize top-end efficiency and managing heat. Let's look a bit closer at these. First up, we've got the Roots and the twin screw types. These are your instant powerhouses. The Roots blower is that classic design you always see sticking out of the hoods of old muscle cars. It uses lobed rotors to physically push air into the intake manifold, building pressure externally. The huge upside here is instant power. The downside, it's bulky and it generates a ton of heat because it's not super efficient. Now, the twin screw model might look similar on the outside, but inside it's a totally different beast. It uses these really complex male and female intermeshing rotors to actually compress the air internally before it even leaves the unit. So you get that same instant power, but with drastically better thermal efficiency. Though, as you might guess, that precision manufacturing comes with a pretty hefty price tag. Then there's the centrifugal supercharger. Instead of those big spinning rotors, this uses a high-speed internal impeller and a diffuser to dynamically compress the air. Honestly, it works a lot like a turbocharger, except it's driven by a belt attached to the engine instead of exhaust gases. And what's wild is that this design is so incredibly efficient at high speeds, it was literally the high-altitude hero of World War II. Fighter planes like the F-6F Hellcat actually use these to maintain engine power in the super thin air at 30,000 feet. No joke. In modern cars, it remains exceptionally efficient, but the catch is the amount of boost you get is highly dependent on how fast your engine is spinning. Okay, let's transition to part 3, real world, the Mustang kit. Let's take all this theory and actually put it in the garage. We're going to walk through a real-world install using an official Ford Racing upgrade kit for a modern classic, the 2007 to 2009 Ford SVT Mustang. Taking a stock engine and retrofitting a supercharger onto it is a pretty massive undertaking. Now, the kit includes obvious hardware, like a high-flow conical air filter and a massive air box so the engine can actually gulp down more air. But take a look at the device next to it, the ProCal Flash tool. This is absolutely crucial. You can bolt on all the mechanical parts you want, but if you don't use this tool to digitally recalibrate the powertrain control module, you're going to destroy your engine. The manual explicitly warns against operating the engine with all this new air without updating the software. It's a guaranteed recipe for catastrophic damage. And here is the star of the show, the TVS 2300 Supercharger. This is a positive displacement pump. In plain English, that means as long as the engine's crankshaft is turning, this thing is actively pumping air. It doesn't need to spool up or wait. It shoves a fixed, massive volume of air with every single rotation. But hey, before we even touch a wrench, we have to talk safety. We are dealing with highly volatile, pressurized fuel systems here.
The manual is dead serious about this, warning that highly flammable mixtures are always present. You absolutely must relieve the fuel system pressure properly before you start taking things apart.
And the step-by-step disassembly instructions show you exactly how meticulous you need to be. You don't just go in and unbolt a fuel line. No way. You literally have to remove the fuel pump fuse F41 specifically, start the car, and just let it sit there and idle until it literally chokes and stalls out. That's how you make sure all the pressure in the manifold is gone. Only after that do you disconnect the battery and start removing the strut tower brace. It really turns our fun physics lesson into a very real, potentially dangerous mechanical reality.
Now, here's a detail that makes actually driving a supercharged car on the street bearable: the bypass circuit. Remember how we said positive displacement pumps are always moving air if the engine is running? Well, what happens when you're just sitting at a red light or barely touching the pedal on the highway? You definitely don't want massive boost then. So during low throttle, a vacuum-controlled valve opens a bypass circuit. This lets the air just circulate freely through the rotors. It prevents pressure buildup, lets the unit idle with almost no resistance, and drastically cuts down on heat and that whining noise. And don't worry, it doesn't hurt your performance. The split second you floor the gas, that bypass valve slams shut and you instantly get full boost.
All right, let's zoom out a bit for our final section. Part 4, the future, electric and diesel. How is this 100-year-old tech surviving today? Enter the electric supercharger. Instead of stealing power from the engine's crankshaft with a belt, these use a completely independent electric motor. It's brilliant because it completely solves low-speed acceleration lag. It can spin up instantly, even from a dead idle. Actually, research is showing they're amazing for small diesel generators working at high altitudes. They provide enough instant air to completely eliminate that nasty black smoke of unburnt fuel. But of course, there's a trade-off. They consume a ton of electrical power. And honestly, they really struggle to maintain high-pressure efficiency at higher speeds compared to the classic mechanical blowers. Which leaves us at a really fascinating crossroads. Production cars like the Audi SQ7 are already rolling out with these electric compressors. With electric motors so brilliantly bridging that gap in low-end power on modern hybrids, you kind of have to wonder, is the mechanical, belt-driven supercharger, this brilliant piece of engineering we've loved for over a century, destined to become just a museum piece? Or will the sheer, raw, high-speed violence of a twin-screw or a centrifugal blower always find a home under the hood of true performance cars? Just something to chew on the next time you hear that unmistakable supercharger whine. Thanks for hanging out with me for this explainer, and keep learning.